All right, so we're diving deep into the history of AI today, tracing its evolution and looking at those key moments. And our guide for this deep dive is a fascinating document called Hoofdstuk 1, die Ontstaansgeschiedenis van kunstmatige intelligentie.pdf, a historical account of AI, really cool stuff.
Yeah, it's amazing to think how AI has gone from this fringe concept to something that's shaping our world. And this document is a great starting point to understand that journey.
For sure. Okay, so let's rewind all the way back to the 1950s. What really strikes me about that era is just the incredible optimism, like it's a wide-eyed wonder about intelligent machines.
Yeah, it's fascinating how the term artificial intelligence itself was actually coined in 1956 at a conference at Dartmouth College. And this gathering of really brilliant minds like John McCarthy, who really envisioned machines exhibiting intelligent behavior, they really set the stage for everything that came after.
Yeah, and this optimism wasn't just hype, right? There were some genuine breakthroughs happening, like Alan Newell and Herbert A. Simon developed the general problem solver algorithm, which was like this groundbreaking attempt to show that machines could actually tackle abstract reasoning.
Yeah, exactly. Like they were trying to crack the code of human thought.
Exactly.
But at the same time as this progress, there was also this undercurrent of, I guess you could say, over-exuberance. Like the expectations for what AI could achieve in the short term were, looking back, maybe a little unrealistic.
Right, like they thought we'd have robots doing our dishes and writing poetry within a few years.
Exactly. And it brings us to this recurring theme in the history of AI, this hype cycle. When expectations get ahead of what's technologically possible, disappointment tends to follow. And this is exactly what led to the first AI winter in the 1970s.
Okay, so let's talk about this winter. Was it just a case of the tech not being ready, or were there deeper challenges at play?
It was definitely a combination of factors. I mean, there were real limitations in terms of computing power. But there was also this growing realization that replicating human intelligence was way more complex than people initially thought. And a great example of this is the Turing test proposed by Alan Turing back in 1950.
Oh yeah, the Turing test. The idea that if a machine can convince a human that it's human, then it's achieved some level of intelligence. Such a simple but powerful concept.
It is. But even today, passing the Turing test in a truly meaningful way is still really difficult. It highlights how hard it is to capture those nuances of human conversation, to really understand and respond in a way that feels genuinely intelligent.
So even in those early optimistic days, there were hints that this quest for AI wasn't going to be a walk in the park.
Exactly, and that realization, coupled with the technological limitations of the time, led to this period of disillusionment and reduced funding for AI research, which we call the AI winter.
And yet, AI managed to bounce back. The 1980s saw a resurgence, driven partly by something called expert systems. So what were these exactly?
Well, expert systems were designed to be really good at specific tasks. Like, imagine a program that could diagnose diseases or configure complex computer systems. That's basically the essence of an expert system.
So instead of trying to create this general intelligence, they focused on making machines experts in specific areas, which makes sense.
Yeah, and this approach was fueled by a branch of AI known as symbolic AI, where knowledge is represented through symbols and rules, kind of like programming a machine with a huge library of if-then statements so it can make decisions based on logic and predefined knowledge.
Ah, so it's like giving the machine a rule book and a whole bunch of facts and then letting it figure things out.
Precisely, and this actually proved to be very effective for certain tasks. For example, there was this expert system called XCon developed in the 1980s that was incredibly successful at configuring computer systems and actually ended up saving its company millions of dollars.
Wow, that's impressive. So expert systems were like a real win for AI.
Yeah.
But I'm guessing there were limitations, given that we eventually had another AI winter, right?
You're absolutely right. While expert systems were great in narrow domains, they struggled with more complex, real-world problems that required flexibility and adaptation. Like, imagine trying to teach an expert system how to drive a car in a busy city. The number of rules and exceptions would just be overwhelming.
It's like they were brilliant specialists, but they lacked that common sense and adaptability of human beings.
That's a great way to put it. And this limitation, combined with other factors, led to the second AI winter in the late 1980s and early 1990s. But even during this downturn, a new approach was quietly taking shape, an approach that would end up revolutionizing the entire field.
Okay, now I'm intrigued. What was this game-changing approach?
It was the rise of machine learning. Instead of explicitly programming all the rules, researchers began to explore ways to let machines learn from data.
So instead of giving a machine a rule book, They gave it a mountain of data and said, figure it out.
Essentially, yes. And this shift marked a really fundamental change in how we thought about building intelligent systems.
So we were talking about machine learning starting to gain some real momentum. It seems like a completely different approach compared to those rule-based expert systems.
It really was, yeah. Machine learning is all about letting algorithms learn patterns and make predictions from data, rather than relying on explicit programming. And, this idea has been around for a while, even going back to the mid-20th century.
Really? So even during those early days of AI, people were already thinking about this data-driven approach.
Oh, absolutely. A good example is Frank Rosenblatt's perceptron back in the 1950s. It was an early attempt to create a machine learning model that was inspired by the structure of the human brain. It's like they were already trying to mimic how our own minds learn.
Wow, so the concept of neural networks goes way back.
It does. But those early neural networks, they were limited by the computing power back then. It wasn't until much later, the late 20th and early 21st centuries, that machine learning really took off. And that was because of advances in computing, the availability of huge data sets and new algorithms being developed.
It's like all the pieces finally came together. Speaking of which, our source material mentions this thing called the Japanese Fifth Generation Computer Systems Project, or FGCS for short. Sounds like they were trying to create a super intelligent computer back in the 1980s.
Yeah, the FGCS was a hugely ambitious project. They really wanted to create a computer that could understand natural language, solve complex problems, and basically mimic human-level reasoning.
That's incredibly ambitious. Makes you wonder why we haven't reached that level of artificial general intelligence even today.
That's a good question. While FGCS did make some contributions to AI research, it ultimately didn't achieve its goals. One reason might be that they were focused on building a very specific type of AI based on logic programming and symbolic reasoning.
So they were kind of betting on one specific path to reach general intelligence, and that path turned out to be tougher than they thought.
Exactly. It shows how the development of AI often involves trying different paths and approaches. Sometimes what seems like the most promising route hits a dead end, while other approaches that maybe seemed less promising at first end up making the big breakthroughs.
It's a good reminder that scientific progress isn't always straightforward.
Mm-hmm.
So let's talk about how machine learning really started to gain traction. What were some of the things that led to its rise?
Well, one really crucial factor was the huge increase in data in the digital age. Companies like Google and Facebook were collecting massive amounts of information, which gave machine learning algorithms the raw material they needed to learn and improve. It was like having a sudden abundance of fuel for these powerful engines.
Data is definitely the fuel that powers machine learning. But I'm guessing there were also advances in the algorithms themselves that played a role, right?
Absolutely. The development of new machine learning techniques, like deep learning, was critical. Deep learning involves training artificial neural networks with many, many layers, which allows them to learn complex patterns and representations from the data. It's like taking those early neural network ideas and giving them more layers and more computing power.
So deep learning is about building these layered networks that can analyze tons of data and extract meaningful insights from it. It sounds incredibly powerful.
It is. And one of the areas where deep learning really made a splash was in image recognition. In 2012, there was this deep learning model called AlexNet, which is a type of convolutional neural network, and it won the ImageNet competition, which is a big image recognition challenge.
Oh, I've heard of ImageNet. It's like the Olympics of computer vision.
Sure.
So this AlexNet model really set a new standard for image recognition.
Yeah, it did. And it's a great example of how good convolutional neural networks, or CNNs, are at processing images. They can analyze different aspects of an image, like edges, textures, and shapes, and then put all that information together to figure out what's in the image.
It's like giving a machine specialized eyes that can see and understand the world in a way that wasn't possible before.
Exactly. And this breakthrough in image recognition really sparked a lot of excitement and innovation around deep learning. It showed that these models could perform as well as humans, or even better, on complex tasks.
So it was a major turning point. And after that, deep learning started to be applied to other areas too, right? Like natural language processing and speech recognition.
Exactly. Deep learning turned out to be very versatile, and it led to breakthroughs in areas like machine translation, text generation, and even playing games like Go.
It's like deep learning became this multi-tool of AI, capable of tackling all sorts of problems.
That's a great way to put it. And that versatility is a big reason why deep learning has become so central to the field of AI.
It seems like we've entered this whole new era of AI, where machines can do things that we used to think only humans could do. And I guess this is where the idea of generative AI comes in, right?
You got it. Generative AI is one of the most exciting and rapidly developing areas of AI right now. It's all about using AI to create new content like text, images, music, even video.
So it's like moving from AI that understands and analyzes to AI that actually creates and imagines things.
Exactly. And this shift has been driven by the development of powerful generative models, such as generative adversarial networks, or GANs.
Oh, wait, GANs, those are the models that can create super realistic images, right? Like those deepfakes that we sometimes see in the news.
That's right. GANs are behind a lot of those impressive and sometimes a little creepy creations. The idea is you have two neural networks competing against each other. One network tries to generate realistic content, while the other tries to detect fakes. And this back-and-forth competition pushes both networks to get better and better, which results in those incredibly realistic outputs.
I mean, it's crazy to think about it.
Yeah.
We've gone from machines that could barely tell if a picture was a cat to AI that can create pictures of cats that don't even exist, like photorealistic cats.
Yeah, it really shows how fast things are moving in AI. And it's not just about making cool images. Either generative AI could completely change fields like art and design, even scientific discovery.
Yeah, I've seen some of the AI-generated art, and it's really impressive. It makes you wonder, what does creativity even mean anymore when a machine can do it too?
That's a great question. It's something that philosophers and artists are debating right now. Are these AI models really expressing themselves? Or are they just super sophisticated mimics reflecting all the data they've been trained on? It's a debate that will probably keep going as generative AI keeps getting better.
And it goes way beyond art. Imagine using AI to design new medicines or compose music or write marketing copy. The possibilities seem endless.
They really do. But like any powerful technology, there are potential downsides too. One concern is how it could be misused. Like imagine people using generative AI to create fake news or manipulate people's opinions.
That's a bit scary. It seems like every time AI takes a step forward, we also need to be thinking about the ethical side of things and how to prevent it from being used for bad purposes.
Absolutely. We need safeguards and regulations to make sure generative AI is used responsibly. And it's not just about misuse either. We need to think about the big picture too. How will this technology affect society as a whole?
Exactly. Like, how will generative AI change jobs and the economy? Will it lead to a lot of people losing their jobs, or will it create new opportunities that we can't even imagine yet?
Those are really big questions, and there aren't easy answers. Some experts think AI will automate a lot of jobs that people do now, which could lead to job losses. But other experts think AI will create entirely new jobs and industries that we don't even know about yet.
It's like trying to predict the future, which is always tough.
Yeah.
But one thing is certain, AI, especially generative AI, is going to have a big impact on society.
And we need to be prepared for those changes. We need to invest in education and training so people can adapt to this new technological world. And we need to talk openly and honestly about the ethical and societal implications of AI.
It feels like we're heading into unknown territory, but it's also really exciting to think about the possibilities.
It is exciting. AI has so much potential. It could help us solve some of the world's toughest problems like climate change and disease. But it also comes with risks that we have to be aware of.
So it seems like the key is to find a balance between embracing AI's potential and being aware of its limitations and the things that could go wrong.
Exactly. And it's up to all of us, researchers, policymakers, business leaders, and everyday people, to work together to shape the future of AI in a way that benefits humanity.
It's a responsibility we all share. So as we wrap up this deep dive into the history of AI, I want to leave you with this thought. The future of AI isn't set in stone. It's something we're all creating together through the choices we make, the actions we take, and the way we imagine the future.
So let's make wise choices, act responsibly, and imagine a future where AI makes our lives better, inspires us, and helps us build a better world for everyone.
Thanks for joining us on this journey through the history of AI. We hope you enjoyed the dive and that you're feeling inspired to keep learning about this amazing and constantly evolving field.